itself is not very hard. It's just, I guess, it's a word problem. So it's just the same concepts, just using your brain to like kind of think and set up the equations. So you're given this set of information right here. So you have these guys bought the tickets for $5 each, and the other guys bought them for $7 each, right? And then in total, we have they spent $1,790, and then the total number of students there that actually bought the tickets are 290. So the first one we can have is just students, the group of students A plus group of students B is just the total number, which is 290, right? And then now we can set up the group that bought the tickets for $5 each, and the group that bought it for $7 each. So times that group number, just how much they paid in total, and 7 times the other group number, which is how much the people who bought the tickets at the door paid in total. It's just the total amount of money made. So it's just 1790, right? So with that, you can kind of, okay, so before we do that, to make it clear, substitution would probably be the best in this case. So this turned into y is equal to negative x plus 290. And you end up with, when you plug it in, it turns into 5x plus 7 times negative x plus 290 is equal to 1790, right? The right side doesn't change. You simplify that, it turns into, I'm just going to distribute it out so it's easier for you guys to see. So what happens when you distribute it? Then you simplify, it cleans up to this. And then to get rid of the negative, you could just do it in 2 steps, but I made it a lot easier. Just move the 2x over instead of the actual thing. So you can just, you're dealing with positive numbers now. So it's, well, I prefer that. You can do it either way, but it's all a matter of preference, right? And then you subtract both sides for 1790, and you end up with 240 is equal to 2x, and x is equal to 120. Now we have this equation here, right? We have the x value as well, so we just plug it in. So y is equal to negative 120 plus 290, and y is equal to 170. So the meaning between these two numbers, when you guys have tests or anything, you guys are most likely going to have to write the units. So for x, so it'd be 120 students bought tickets in advance, and then 170 bought at the door. So that's this problem. Are there any questions? All right, so let's move on. So for the goals of today, we're going to be going over exponents, radicals, and irrational numbers. Where mainly the majority of the lesson will be on the fundamental concepts of exponents and all the different rules that apply to them and the properties we use to kind of manipulate them. And then after that, we'll be covering a little bit on radicals and how we simplify them. And then after that, just like kind of a broad concept about rational numbers and irrational numbers. That one should be pretty simple for most of you guys. So let's move on. The first law of exponents that we'll be addressing is the multiplication rule. It's pretty straightforward. It's written out here. So when two exponents with the same base, this is the base right here, are multiplied together, you just add the exponents together, which are these. So they turn into a equals a to the power of x plus y. And keep in mind, this is the really important part that some people might get mixed up on. These two bases have to be the same. Otherwise, this rule doesn't apply to that. So if it doesn't, then you probably either have to manipulate something to fix it, or to like simplify it, or you just can't do it. So we have a problem here with integer values, so it's easier for you guys to see. So this symbol is just exponent symbol for those of you guys that didn't know. So 2 to the power of 3 times 2 squared is equal to 2 to the power of 3 plus 2, which is just 2 to the power of 5. So this concept should be pretty straightforward. So let's practice with a few problems. Next slide, please. All right, so majority of these should be pretty simple. One of them might be a little tougher, but I'll give you guys 2 minutes to work on it. So I'll just go through and put the answers up for you guys. For one of them, I actually will show the work. For the rest of them should be, we'll explain a little bit. The rest of them should be really straightforward. So for this one, the bases aren't the same, right? So we can't directly apply the rule. So here, it's 2 to the power of 8, right? And we know 2 squared is just going to be 4. So with that, this just turns in this value right here with a concept, I think, well, if you guys don't already know, it will be covered later. We'll elaborate on a little bit more, but this just turns into 4 to the power of 4. So this just turns into 4 to the power of 4 times 4 to the power of 8, which is equal to 4 to the power of 12. So that's just this section, and we'll move on to the next rule. So next one is the division rule for the law of exponents. It's pretty similar to the other one, and we just covered the multiplication rule. So when you divide them by one another, you can just subtract the bases. Another way we can write this, subtract exponents, I mean. So another way you can write this is just e to the x over a to the y. And they just subtract y from x. It's a lot more easy to visualize with this way of writing, but the concept is exactly the same. So here we have 2 to the power of 5 divided by 2 to the power of 3. So this is just the same thing as 2 to the power of 5 minus 3 is equal to 2 squared. If you just want to check on your own, you can just plug in 2 and just like solve it arithmetically. But this, you'll come up with the same answer. And yeah. So if there's no questions about this concept, we'll move on to some more practice with regarding this, applying this rule. We'll give you about a minute, 2 minutes for this as well. All right, so I'll just go through these problems now. First one, you subtract 2 from 10, you get 10 to the power of 8. Second one, same thing, just direct subtraction. That's 8 to the power of 9. The third one, this one we're going to go into negative exponents, which we'll cover later. But this, you just subtract 33 from 4 and you get x to the power of negative 29. And this last one is applying the same concept that you used in the previous problem of the sort. So to get 16, right, from 4 to 16, you just have to square 4, right? And when you square it, you have to take away from this. So this 4 to the power of 8 would have the same value as 16 to the power of 4. And then you divide it by 16 to the power of 3. It turns into just 16. Are there any questions? All right, if not, let's move on. So for this problem, it's just, this will kind of explain exactly what we just did earlier. So this is power of a power. So when you have a base raised already to an exponent, and raise it to another exponent, you just end up multiplying the two exponents together. So yeah, when we put this into numerical terms, or integer terms, this is what we end up with. So if you write it out, it looks like this: 3 to the power of 2 to the power of 3, right? And if you can see, you just multiply these two together again. So this turns into 3 to the power of 6, right? So if we look at the question we just did earlier, this is 4 to the power of 8, right? So we can split this up into 4 squared times to the power of 4, right? When you multiply these together, it's still to the 4 to the 8, right? But then when you look at it this way, it explains why it turns into 16 to the power of 4, because inside is just 16 to the power of 4. So these are all the same. So there's just a little bit of algebraic manipulation you can do with these laws. Are there any questions? All right, let's move on to some practice in this section. All right, so I'll just get started on these. So for the answers to these ones, all right, let me get the pen out. You just multiply 6 and 7 together and turn into 2 to the power of 42. This one you multiply the exponents together as well. It's turned into 8 to the power of 8. Same thing with these. It's that there's a negative, so don't forget about that. It turns into x to the power of negative 8. This one, you multiply these two together, so it turns into 3 to the power of 4. So if you wanted to do this the other way, you could just have 9 on the inside, so it turned into 9 squared. And you can see how this is the same as that, because 3 to the power of 4 is just 3 squared squared, right? That's 3 squared squared, right? It's still the same number, but 3 squared is equal to 9. So you can kind of see why they're equal to each other. If there's no questions, let's move on to the next concept. Well, next law. For this one, it's the power of a product. So it's kind of similar to what we did earlier. You can also apply it if you have an exponent inside, but this, it's just kind of like the law of distribution, right? The property. So for this one, when you have a exponent above the in regarding the whole parentheses, you can just raise every single power base inside the parentheses to that power. So for example, this written out would just be like 2 times 2 to the squared, right? This turns into 2 times 2 squared is equal to 2 squared times 2 squared, because you just distribute the same words. Did the screen just turn black for all of you guys, or is that just me?
Yeah, it turned black.
Yeah.
Okay, it's back. It's back for you guys, right?
Yep.
Yes.
All right. So were there any questions on this concept? All right, let's go to the practice problems here. Could we move on to the practice problems, Ray? I think his PC might have crashed.
All right, I'll see if I can share the slides.
All right, we're having some technical difficulties. Give us like 1 minute.
All right, I'm gonna screen share now. Hopefully this will work. All right, do you guys see it?
Yep.
Could you go
All right.
back a few slides, Leonard?
Sure.
We're on the
Even more. Is this forward?
products. No, go back. Go back a little bit more. Go back. I think it should be this one. Just
This one,
start
right?
sharing that
Yeah,
slide.
I think it's this one. All right, so just 5 problems.
All right, these are the practice problems for the concept we just did. So go ahead and I think I'll give you 2 minutes for this one. All right, so for these ones, this is power of product, right? So this one, I'll just write out some work for you guys. Well, just individual terms, so it's not all combined into one. You can also write this as 12 to the 5, just because it's an integer value. It's really easy for you guys to simplify in a different way. But for these ones that are just the base is a variable, you guys should write it out this way. And then this one is you just distribute this the squared inside to both values. So it's a mix. So try not to, it shouldn't be too hard to not get confused. And all right, this one might have been a little bit harder than the rest of them. The other ones are really straightforward. So just to write this out, this is 2a squared negative 2. We're going to cover negative exponents more in detail. So if you don't get it right now, it's fine. So, but the concept is you just distribute this inwards, right? 2 to the power of negative 2, just 1/4. So we have 1/4 here, right? And then 2 to the power, a squared to the power of negative 2. That'd just be a to the -4, and when it's negative to the power of -4, you just move it to the bottom and get rid of the negative. So the answer for this one would be this. So if you didn't understand the explanation for number 5, it should be fine. We'll cover the negative exponents in a short bit, but were there any questions on the rest of them? If not, let's move on to the next concept. All right, so this one is similar to the power of a product rule. You just distribute the exponent inside to the terms within the fraction instead of the product this time. So still the same concept, essentially. So yeah, so for this one, the integer example, 1/2 squared, you distribute the square into both the top and bottom since they're both terms. Doing the 1 squared over 2 squared is just 1/4. So that would be the power of a fraction rule. Are there any questions? All right, let's move on to the practice problems. I'll just write them in now so we can move along a little bit faster. All right, so the first 3 should be relatively straightforward. You just directly apply the rule and you get the answer. The 4th one has kind of like a secondary step for the bottom half. It's applying like the product rule and also kind of the power of a power rule that we just covered earlier. So when you distribute the squared in, you have to distribute to the 5 and the x squared. And when you distribute to the x squared, it turns to x to the power 4 because you're multiplying them together. So it turns into 16 over 25 to the 25 times x to the 4th. Were there any questions? All right, let's move on. All right, for this one, this is probably the most simple and straightforward rule of all. Any value raised to the power of 0 is just equal to 1. So it doesn't matter what this a is, it's just equal to 1. So this super large number raised to the power of 0 is just equal to 1. All right, let's move on. Next slide, please. All right, so these are really straightforward. I'm just going to do them with you. This value doesn't matter what it is raised to 0, it's just equal to 1. This value also raised to the 0 is equal to 1. This one is 4 to the raised to the 0, which is 1 over 3. So yeah, that would be these 3 problems. Are there any questions? If not, let's move on. All right, now we're getting to the law of the exponents for the negative exponents, like I talked about earlier. It's pretty straightforward. To get rid of this negative exponent, you just swap it into from the denominator. Like this would just be a to the negative x over 1, pretty much, right? That'd be the fraction form. You just swap it from the denominator into the numerator and vice versa. So if this question was a to the, so if this question was a to the 1 over a to the negative x, this would just be equal to a to the x. So you just swap them around between the numerator and the denominator to get rid of the negative. So for this one, it's 3 over x to the negative 2. Oh. And then to get rid of this negative exponent, we just put it into the denominator instead. So this turned into 3x squared. This just gets moved up. Are there any questions? If not, let's move on. I'll give you a minute to do it before I start writing in the answers. All right, so I'll start writing them in for you guys now. This is the problem we worked on earlier. Hopefully it makes a little bit more sense now. So this just turns into 1 over 4 a to the power 4. This one turns into, okay, so this one, I might just write out the steps. It might be a little bit confusing just because it's a fraction. This turns into, to get rid of the negative exponent, you just turn into this, you swap between the numerator and the denominator, remember? So this just turns into the reciprocal. And then from there, you could just apply the power of fraction rule, turns into 10,000 over 81, but you don't need to do that. And then this third one, it's 1 over 3x to negative 2. This just, this gets moved up, and this just turns into 2x squared. This last one is 4x to the negative 3. You can move this down. So just remember that, be careful, these are two different terms. This is a coefficient, so the coefficient doesn't need to get moved down. So only the thing that's getting raised to the negative exponent needs to get moved down with it. So this turns into 4 over x cubed. Were there any questions?
No.
All right, let's move on. I think, again, this one should be a relatively simple concept. It's just kind of writing things out in a certain format. So this is a to the x over y. When you raise it, just keep in mind that when you raise it to this, just remember that we're getting raised to that. And when it's divided, it's kind of like, it's just a square root to a certain power. So this would be just a root to the root y, right? If we have a specific integer value, it might be a little bit more clear. So you have x to the 8/3. This is in the denominator, so it's still, so it'd just be what x is raised to itself. So x to the 8. And then what's in the 3 right there would be moved out to be the power of the root. So this would be a cube root. So root 3, pretty much. So that's how you would convert this fractional exponent into a different form. Yeah, okay, let's move on. We're running out of time, so I'm just gonna do them along with you guys. So yeah, just go ahead and work on your own. Check, you can look up and check on the screen if you'd like to. All right, so these will be the answers for these 4 problems. There's no questions. Let's move on to the next concept. Right, so now we're going to be moving on to radicals. So at first, this might be a little bit more tough to get the hang of, but you guys should all still be fine. With radicals and roots, you can split the term within the square root to like however many parts you would like to. Because just make sure when they're multiplied together, they still equal the same as the original. So let's just do an example with this value right here. So it's root 125n, right? So you can split this into inside, just make sure the inside is still the same. It's 5 times 25 times n, right? 5 times 25 is 125 and n still there. And with these square roots, there's a property, you can just split them into separate square roots as well, as long as they're all the seconds, like a square root and not some other root. So 5 times root 25 times root n. You can always do that, but you don't need to. For example, in this case, splitting our 5 and n is not necessary because we can't really do anything with it. The only thing we can really factor out is the root 25 because we know root 25 is just 5. So this turns into root 25 times root 5n. Root 25 is equal to 5, so this just turned into 5 times 5n. So with these radicals, you kind of just play around and just think about what square roots or what squares you can factor out. Just keep in mind values like 36, 49, 64, 81, stuff like that. All right. Are there any questions? Let's move on. These might be a little bit tougher, so I'll give you guys 3 minutes to work on them. All right, so I'll just start working through them now so that I'll write out some more steps so it's easier for you guys to see. And yeah. So for number 1, it's root 5400. The most obvious thing you could see is just 100, which is just the 10 squared. So we can factor out 100, root 100 times the 54 is still there. Remember, these have to equal the original thing when multiplied together. So here we have 10 times root 54, which we can split. If we look at 54, we can split that into 9 and 6, which 9 is just the 3 squared. So this is root 9 times 6. And root 9 is just 3, so that turns into 30 root 6. So that's number 1. Number 2 is root 45 x to the power of 6. For this one, 45, the coefficient is not a square itself, so we can factor that something from that. We have x to the power of 6, which we can always divide by 2 with because of the square root. So we're going to try and get 9 and factor out 5. So this turns into 9x to the 6th times root 5. And this, when you take the square root of it, it just turns into 3x cubed root 5. So that'd be answer for number 2. Number 3 is, I think, the most simple of them, just an integer thing. You can do it in different ways. The most straightforward way for most people would just be divide it first. This simplifies. This is the same thing as root 16, which is just 4. And number 4, this one's a fraction. So 25p cubed divided by q squared. So here we can, since we can split things up, right? So we can also split the numerator and the denominator. So this is the same thing as root 25p cubed over root q squared. So this turns into the top p cubed. You can't really divide that by 2, so we're going to take one p out. Turns into 25p squared root p. Bottom is just q squared square root, and that obviously is just q. So we have at the top 25p squared. 5 squared is 25, and the p squared is p squared. So this one is just 5p root p over q. And number 5, that's big. Okay, I'll just write that down here in the corner. So this one's another fraction. So root 75 divided by 16x squared. Again, we can split up the square root into the top and the bottom. So root 75 over root 16x squared. 16x squared is pretty straightforward. It's just 4x squared. So turn into 4x. The top, on the other hand, you'll have to split this apart. 75 ends in 5. So for my first thought, just look for 25s in there, which you can. So you split this into root 25 times root 3. And this just turned into, since root 25 is just 5, turns into 5 root 3 over 4x. Are there any questions? All right, let's move on. All right, so this is a pretty basic concept most of you guys should have already learned in school. We're just going to review it one more time. So there's rational numbers, integers, whole numbers, and natural numbers. They're all split into the rational number category. On the other hand, we have irrational numbers, which include infinite things like pi and all the square roots, stuff like that. These all fall under the category of real numbers, which I don't think you guys need to be worrying about I or things like that just yet, imaginary numbers yet. So this is pretty much all you need. To differentiate them, the rational numbers as a whole includes the infinite decimals, includes the negative decimals, fractions, stuff like that. Just non-whole numbers, not all just all non-whole numbers, yeah. And then integers, these will just be whole numbers, like numbers that aren't decimals or fractions, right? As long as they come out without a point something 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 after it, that would be considered an integer. For whole numbers, their weird definition, it's just whole numbers are all the positive integers, including 0, such as 0, 1, 2, 3, 4, 5, 6, 7, onwards. So a -5, even though you might think there's a whole number, is not. And natural numbers are even smaller category. These are, well, it's just whole numbers, but without 0. It's, yeah, whole numbers without 0, because they're already all positive. It's just one number that is included. And on the other hand, irrational numbers, you have things like pi, which aren't, well, just goes on infinitely and doesn't repeat. And we have our square roots. And this term, I think you guys really don't need to know this, but this one specific decimal that just goes on is also considered an irrational number for some reason. You don't need to worry about that though. All right, let's move on to some quick practice problems of identifying before we're done with class.
Wait, what are we supposed to do? Are we supposed to list all of them?
Just determine whether they're rational or irrational.